Welcome back. At the end of our last tutorial, we have our character Corey, and the controls work using async communication. We can also adjust the speed as he's moving, and there's bounds detection. We achieve this. At the top, we're using threading, queue, and a time to sleep so that the frames come out at a reasonable pace. Today, we're going to refactor our application to use a Python package called asyncio only. This concept of threading, although great for education, will actually not work in the browser. And the reality is that in many systems, managing the queue and the thread individually is maybe a little bit too complex and potentially prone to errors. So in our current game, we are starting the threads ourselves, and we're putting the thread into we're putting a message into a queue for the different threads to use to communicate. Although this gives you a more granular understanding of what is happening with async communication, this will not work in a web browser with FLET because of the underlying technology of we're using something called Pyodide when we deploy it. Additionally, frameworks like FastAPI and Node.js use async. So we're going to refactor it. So since you learned the basics, we'll touch on something that's used more in production. So we're focused on event loops and cooperative multitasking. We're going to delete these three imports, threading, time, and queue, that the previous tutorial was focused on, to show you the concepts which you will need in your future schooling in CS. We're going to keep the asyncio, which is the main package that Python, well, in my opinion, the main package Python uses nowadays for async communication. We're going to look at the queue, find the queue. We're going to delete this. We no longer have the package. And this entire check update, we're going to delete the function. And since we don't have a queue, we're not going to use this convention here. All right, we don't have the threading anymore, and so we'll need to get rid of this, but we still have a game loop, and we still have these threads right now. So let's delete the threading, and then we will delete update the queue. We don't have the queue, and we don't have the time. Okay, so we're going to put the page update inside of the game loop. Update. Oh, page.update. So this page is from FLET. And then we're just going to put the await async IO, just a package we imported from Python. And we will make our game loop asynchronous with the keyword async. And we're going to start the async loop. previous page.run task game loop, and we'll test our system again. Let run main.py, and it appears to work. Beautiful. Okay, we took the learning from managing the threads somewhat manually with the threading, the queue, and the time.sleep to block it on specific threads. But the threads don't work in the web browsers. In our stack, we're using something called Pyodide to run the Python into the browser, and something called WebAssembly, or WASM. Modern systems, including RStack, FastAPI, and FastAPI, they're using this async for I/O tasks. And the industry standard has moved to async patterns. You will need to learn about the thread concept if you continue your studies in computer science. These producer-consumer patterns, race conditions, which is a problem with threading and shared state coordination. These are going to be covered in your operating systems class, fundamentals. However, modern stacks, including FastAPI and FastAPI, use this async await pattern. The cloud services that you'll be using, like AWS Lambda, GCP Cloud Run, use async. The databases, including the FastAPI stack, use async drivers, such as async PG for PostgreSQL, which we are using, as well as AIO, async IO SQLite, which we also use. So if you continue with our course curriculum, you'll use all of these concepts. The web browsers, due to Pyodide, can't use the Python threads at all. Again, you learned the threading because you'll need to cover it in your operating systems class, or it's just good to know the concept even if you don't continue in a formal curriculum. So this is the old architecture where people had to do it this way before. The new architecture, which is async and await like this. There's no thread, at least there's no thread manually managed, there's no queue, and there's no check update for the function. First step is that we did remove the imports for these packages that we decided not to use, and we're using the async IO that will handle the sleep. We're not using the queue in our current model, and we converted the game loop from synchronous to asynchronous here. There's this async keyword here and the async io.sleep. So our previous flow was button state. All right, so this is the button. We change the state. We create a thread. We're dropping the message from the thread onto the queue with async check and a UI update. Modern flow is button state async loop and UI update. So our simplified flow, we have the event loop. It manages the async tasks. Most of the work that you'll be doing in the industry, or maybe for your projects, will use the same type of modern async system. It's relatively straightforward. Async await, async for the asynchronous function, await to yield control, and wait for the result. And there's a non-blocking execution. So the async will work everywhere. Desktop, web server, and it's the industry standard nowadays. You'll see this pattern in FastAPI, FastAPI. We're using it for the async endpoints, the database drivers, web frameworks. Django now has async, or Flask also has async. Cloud services, which will be using databases. When it's using the asynchronous driver, we use it with an async session using SQL Alchemy in the future, and web browsers, which it won't support the threading at this point. Repeating the concepts, event loops and cooperative multitasking. Async await syntax and usage pattern, which is common in most of the languages nowadays. Why we're using async instead of the queue, the thread that you might be learning in your OS class. How to refactor the threads into this async type of flow. This process of reworking the code for the same functionality, we're calling it refactoring. There's this async pattern, which you'll be using again and again. And you'll probably see it in other people's code if you start looking at it. And this will set us up to build web-compatible applications. So congratulations. You now understand the basic and most common async pattern. You also understand why we are using async going forward instead of the threads, except we may deal with the threads for additional practice because it will come up in future courses that you might take in your schoolwork, and we want to prep you for those courses. It kind of gives you a basic understanding. Event loops, modern concurrency models. You might be using async in your personal projects for async database calls, especially for maybe problem solving. You don't normally need async database in the real world unless your application is kind of a high concurrency, or it's become super popular. Integrate async API requests. We'll learn what async generators are, explore FastAPI patterns. And in the next video, we'll try to get your app live on GitHub pages so you can show your friends and family with your own graphics.